eraser.
Okay, that's a radical equation, right? So to solve a radical equation, the trick is first step, get one of those radicals by itself. It's going to be possible to get them both by themselves, but get one of the squares by himself. And does anyone remember, based on what I said in class, which one I think you'd be better off getting by itself?
Yeah, the smallest one.
Yeah, the uglier one, which is the 4p plus 5 one, right? 281, 557, 7941. Anyone's mom or something like that? Looking for you, maybe? No? Okay. I told her not to call me. Alright, so I subtract that over. Now what? What was the purpose in getting that one squared by itself? Yeah, square both sides, and that's going to cancel the one square root. It's not really going to cancel the other one. That'd be awesome if it did, but it doesn't. So I'll do the left if you do the right. Remember, you're actually boiling that out.
9p squared minus 54p plus 81.
9p squared?
It's 9.
Oh,
It's 9 minus
Oh, okay.
6.
square
The
root
square root of p plus 5.
plus b.
Is there anyone that wants to work that out together? Because you were not successful in getting that and you can't figure out why? It's okay to admit it. It's part of the learning process. Okay. So this is 3 minus the square root of 5 times 3 minus the square root of p plus 5. The 3 times the 3, that's our 9. That's minus 3 square roots of p plus 5. And remember, these don't really get multiplied together because this is not underneath the square root and this one is, right? And then when I do this product, I get the same exact stuff because I'm multiplying the same exact numbers together. If you haven't picked up on that yet, when you're squaring like two terms and you're squaring a binomial, these two terms here should always be identical because you're always multiplying the same two numbers here as you are here. And then negative times negative is positive. And the square root of p plus 5 times the square root of p plus 5 is p plus 5. And so what we got was the 9 here. When I put the two square roots together, minus 3 of them, minus 3 more of them is minus 6 of them altogether. And then your p plus 5, which we can take one extra step and combine those together. That's 14 minus 6 square roots of p plus 5 plus p. So by squaring both sides, I ended up with, once again, a radical equation, another square root, right? So I got to get this square root by itself, or as much as I can by itself. So I'm going to subtract off the 14. I'm going to subtract off a p. So I get 3p minus 9 equals the negative 6 square root of p plus 5. And what we worked in class was we divided that negative 6 off. But if you try to divide off that whole full-blown negative 6, you're going to get fractions, right? So don't do fractions, but is there something that the negative 6, the 9, and the 3 are all divisible by? We can at least divide off 3 so that when we get to squaring we have smaller numbers. So I'm going to divide by 3, divide by 3, and divide by 3. So p minus 3 equals negative 2 square roots of p plus 5. We're almost a third of the way done. Now we square both sides. And when I square the left, is that p squared minus 9? P squared plus 9. When I square p minus 3, am I just squaring the stuff on the inside? Say no.
P minus 3 or 4.
What?
P minus 3 on the left,
Yeah.
on the square,
Yeah.
4.
Right. And when you do, you get extra stuff. You get a minus 6p out of that. If you don't have a minus 6p, that's like a disastrous mistake for your problem, because I really can't grade it after that. If there's a time and place when you're supposed to be foiling and you don't, then you derailed the whole problem, and I really can't look at anything else you're doing. I hate to tell you that. It's bad news, because hopefully nobody does it, but I'm going to bet somebody does. Over here, when I square, this is a product, so I have to square these guys individually. When I square -2, I get, and when I square the square root, those cancel and I get the t plus 5.
And then you multiply.
And then I distribute, so I can get my quadratic equation in standard form. This is p squared. I'm running out of chalk. P plus 20. Boom.
P minus 11, P plus 1.
Yeah. I'm just waiting for everyone to sort of catch up.
So, you can do the fractions if, like, you forget to do that, though?
You can. It just
Well,
makes
so
it a tougher problem.
Yeah, it's ugly.
Yeah.
I have, like, 1/4 x squared minus 3/4 minus 3/4 plus 9/4.
Oh yeah, duh. It's just
But, I mean, you just take off the 4, but
yeah. You would clear fractions multiply it by 4, and you would get
it was still ugly.
similar. No. Okay.
Yeah, I got the same answer.
Yeah. Even if you don't divide at all, you could, but you would once again end up with unnecessarily large numbers. And when you got to your quadratic equation in standard form, there would be a GCF that you could have factored out. Yeah. Okay, are you ready to go on? To finish the problem, I mean? Sure. Okay. So one potential solution I get is p equals 11. The other potential solution I get is p equals -1. But the reason they're only potential is because I haven't checked them, right? I've warned you that I want to see with my own eyes where you put the pencil to the paper and you checked those solutions, right? On your take-home test, you have a radical equation or two where I ask you to solve, and if you don't check, I'm saying no partial credit, right? So even if you had wrong answers and I don't see where you checked, heavy-handed hinting here, right? Make sure you check. Do you want to check the 11 or the -1 first?
-1.
-1, because it works. So does the square root of 4 times -1 plus 5 plus the square root of -1 plus 5, does that really, really equal 3? And I think it does, because this is -4 plus 5 is 1. That's the square root of 4. And that's 1 plus 2, isn't it? So -1 does work. Does 11 work? Four times 11 is 44, and 44 plus 5 is 49. I don't know, I got a bad feeling about this.
7 plus 4.
7 plus 4 is not 3, but what is 7 minus 4? So does it work? If I just change it to minus, it works, right? So my solution said? -1. -1 only.